Welcome. Let's solve Leetcode 2661 first completely painted row or column. All right, let's make this bigger so we can read it. All right, good. You're given a zero indexed integer array and an m by n integer matrix where both contain all the integers in the range 1 to m times n inclusive. Go through each index I in array starting from index 0 and paint the cell in matrix containing the integer stored at index I in array R. Return the smallest index I at which either a row or column will be completely painted in matrix. All right, cool. Let's go over this example here. So they gave us the array 1, 3, 4, 2, and matrix 1, 4, 2, 3. So if we start with 1 here, this upper corner matrix gets painted. Sorry, upper corner left cell of the matrix gets painted. Next 3, so 3 is this bottom right corner gets painted. Next in array is 4, which is this upper right corner, and we can return the value too, because it just so happens that both an entire row and an entire column are completely filled at this point. Okay, I think that's straightforward and easily to understand, or easily understood. So I don't feel it's necessary to go over example 2. Okay, let's go over this here. My approach is, I think what we'll do is we'll use a counter, so to speak. So it'll be something like this. We'll have let me just move this out of the way. So we will use a counter for the row and column. We will also initialize a map between the value in matrix in the matrix and its location. Okay, I think that's about it. I think a large part of the explanation will become clear as we code it. Okay, all right, let's get started. So I think it's fair to say that what we'll need to know is we'll need the dimensions of the matrix. That's typically always helpful and typically utilized. So let's get the row and column dimensions from the matrix. We'll say length of m and length of m0. So now we know the dimensions of our matrix. So that'll help us store its location when we initialize the map between the value and its location. Next, we'll create our counters. So what do our counters look like? So this is where it's going to be a little bit interesting. So we'll say column times row and row times column. Okay, let's look at or examine what these represent. In the meantime, we'll return just 0 so we don't get an error. And let's print R. And these are our counters. Okay, let's print it out. So what I've done is I've created an extra test case because in the examples they gave us, so this is 4, it was a 2 by 2, so it wasn't very helpful. And I wanted us to see this is a 3 by 3. So I want us to see the difference. So here we go. So here, remember I created this, it's basically a 3 rows by 2 columns. So the input matrix I provided is 3 rows by 2 columns. And so notice here how each of the rows, the length of rows is 3 to represent each of the rows. Let me just print that out just so it makes it easier to see. So it would look something like this. So 1, 4, 6, 3, 2, 5. That's how our matrix would look. So notice how at index 0 we have 2. So 2, 2. That's what each of these represents. So each index represents a row count. And notice how the columns, there's 2 columns, and for a column, each column has 3 3 rows, so to speak. So that's why in order for a column to be completely painted, it needs to this would have to be 0. So that's what essentially we're doing. We're initializing the counts of what they start with, and as we'll loop through it, we want to check if any of these equals 0. So again, I hope that makes sense. Remember, this row is for each of the rows and how many are needed to be painted. So let's maybe write that down. So we can say represents counts remaining to be fully painted for row, column, respectively. Okay. So now let's initialize. Remember, we need to initialize the map between the value and where its location is. So we'll say so we'll have a dictionary here for storing that. So we'll say, okay, for let me see. So for R in range, let me make this bigger. Range row for C in range column. So we'll do something like this. We'll say D of the value in the matrix. So this will store where it's located. So MRC equals where its location. So maybe let's print this out so we can inspect what's happening here. So let's maybe print for, let's see, KV in D.items. Print. I don't know if we, let's see. I think this is okay. Okay, let's print it out so we can, let's inspect what's going on so far. Let's use this one here. So in our matrix, we have 1 stored at the location 0, 0, 4 stored at the location row 0, column 1, and 6 located at row 1, column 0, and so on and so forth. So that's what we have. And what we'll do next is we'll loop through our array and subtract our count. Okay, so let's do that. So we'll say, okay, so for, now remember they ask us, our goal is to return the smallest index I. Now the index I from the array. So return the smallest index I at which either a row or column will be completely painted in matrix. So we'll do that. So we'll say for I, that'll be the index in array, and maybe that value in enumerate A. So what we'll do is we'll adjust the counts. So what do we do? How do we adjust the counts? So we can say maybe so RC, so the row count equals, so we want the value stored at, the location stored at this value here. So we can say D of V. So remember we stored where this value is located at. And now we're going to pull them out. Okay, so row and column. Remember, it's a tuple, so it comes out as a tuple. And now we need to adjust the count. So in our row, we can remove that row. And we can take 1 away. Same thing for the column. And we can subtract 1 from that column. So for example, let's look at what we had up here. Let's maybe make this smaller. So just suppose that, so in our array, so well, remember we're looping through this array here and we see 1 here. This is a 1. So then we go to our dictionary and our dictionary looks like this here and it says 0, 0. So then now we look in our counter for the row and column and we subtract. So what we can do here is maybe let's print this out just to make it easier. Let's say maybe let's print, maybe just print, let's print all of it. So let's say print f of r and c and c. So let's print those out as we move along. Let's print it out. Okay, let's print it out. Let's go to example 3 here. So here we go. So remember, I probably should have printed out. It's fine. So we loop through this value 1 here. So 1 is in the array, in the matrix is at 0, 0. So for the row it's at 0, so this gets decremented. For column it's at 0, so this also gets decremented at 0, the 0th index. Okay. Then we look at 3. 3 in the matrix is stored at row 0, row 1, column 1. So row 1, which is here, gets reduced, and column was that column 1? Yeah, column 1 also gets reduced. So this gets reduced from 3 to 2. Okay, then next we have the value 4. 4s are stored at row 0, column 1. So row 0, which is, well, here, now this gets reduced to 0. Column 1 gets reduced, so this is from 2 to 1. And then we should just perform a check here. Once we get to the 0 here, we know that an entire row has been painted, so we can return here. So let's perform a check for that here. So we can say if r of r equals 0 or c of c equals 0, we can just return I. And that should be it. Let's test it. Okay, let's submit it. Okay, looks pretty good. All right, if you found this video helpful or educational, please consider liking or subscribing, or both. Other than that, have a wonderful day. Take care of yourself. Cheers. Bye-bye.